The next type of problem we're going to look into is another complex circular motion problem, but this time there's an angle involved. So if you've been to an amusement park before, you may have noticed a ride similar to what's shown, a swing ride. So the people sit in seats and they swing, and usually the apparatus moves circularly, and sometimes it tilts at an angle as well, but we're not talking about it tilting at an angle. We are particularly talking about it just moving in a perfectly horizontal circle. If you want to see what this ride looks like, here's a YouTube link right below and you can watch that yourself. So basically here's our drawing for the swing ride. We have the person sitting in a chair. There makes an angle theta, and then the radius r. Theta is with the vertical here in this picture, however it could be given with the horizontal instead. The other thing you might need to know is the mass of the person. Okay, let's do an example. So we have an amusement park ride swings, which have a radius of 8 meters and make a 60-degree angle with the vertical and a 70-kilogram rider. We need to find the following: the free body diagram. We need to sum up the forces, the tension, velocity, period, and revolutions per minute. Let's start with A, free body diagram. So in this free body diagram, you'll notice that the tension is at an angle. So it's in the direction of the cable. Force of gravity is straight down due to the weight of the person. Since tension is at an angle, it's going to break up into its x and y components. We're probably going to need those, so let's go ahead and solve for them now. So the x component, since our 60-degree angle is up here with the vertical, x is the opposite side relative to the angle, so we're going to use sine. And ty, relative to the angle, is the adjacent side, so we're going to use cosine. For part B, let's sum up the forces. So for the x direction, we only have one force acting in this direction, so there must be an acceleration. The forces are not balanced, and our acceleration is a centripetal acceleration. So sum of the forces in x is equal to our tx, which was t sine 60 degrees, equals ma centripetal. So eventually we're going to need t sine 60 equals mv squared over r. We just substituted v squared over r in for acceleration centripetal. For our y equation, we have two forces acting in our y equation. We have ty up, which was t cos 60, and we have fg down, which is negative fg. All equals ma, but the object is not accelerating in the y direction, so that equals 0. So t cos 60 minus fg equals 0, which we just set equal to each other. Part C, we're looking for tension. So when we're looking for the tension, we'll notice in some of our forces in the y direction equation, we had tension and force of gravity only. So let's solve for tension. Tension equals Fg over cos 60, which equals mg over cos 60. Plug in our givens. Mass is 70, gravity is 9.8, cos is 60 degrees. We get a value of 1,372 newtons. This was derived, once again, from our sum of our forces equation in the y direction. Now to find the velocity, we're going to use our sum of our forces in the x direction, because that's where velocity is involved in. So let's solve for v. We end up getting r times t sine 60 all over m. So we multiply r on both sides and divided by m on both sides and take the square root. This is what we would get. Now we're going to plug in our givens. We have a radius of 8 meters, tension of 1,372 newtons, sine 60, and a mass of 70 kilograms. We end up getting a velocity of 10.8 meters per second. Now we're looking for the period. The period is the time for one revolution, so the time for that person to go around one time. Well, we may need to use our velocity equation that we know, because last part D, we found velocity. So if we're looking for time, let's solve for t. So t is going to equal 2 pi r over v. And we use 2 pi r because that is the distance of one revolution, the distance for the person to go around the circle one full time, the circumference. Plug in our givens, 2 pi times the radius of 8, divided by 10.8 meters per second. And we get 4.02 seconds. So it takes the person 4.02 seconds to go around one time. So if we're looking how many revolutions is this in 1 minute, if we're able to go 1 in 4.02 seconds, we know that there are 60 seconds in a minute. And if we have 60 seconds divided by 4.02 seconds per revolution, we would notice that we have 60 divided by 4.02, so we have 14.9 revolutions in 1 minute. So basically, how many of this can fit into 60? 14.9.